Video is to review geometric series and how to evaluate a finite geometric series. There'll be another video on how to evaluate an infinite geometric series. So let's get started. As usual, there is a little formula that you can use to evaluate a geometric series. And again, just to review, a geometric series is going to be the sum of a list of numbers that we call a sequence. And geometric series are the ones that are separated by a common ratio, which is going to be using multiplication. So a lot of times the first thing you have to do is find the common ratio, and then you can use the formula. So let's walk through the formula. The first symbols on the left represent the actual thing that we are looking for, which is the sum of all of the terms. Okay? On the right, this is where we have to have three things in order to fill it in. We need to have A1, which is the very first term. We have to have R, and that is your common ratio. And then we have to have N. And N is going to be just the number of terms that you're going to have. And again, since it's a finite series, there will be a number of terms. So let's take a look at example number 1. First, let's try and find some of these. We have A1. A1 is the first term. So let me go ahead and write that one down. A1 equals 3. This is your first term. Now the common ratio isn't shown, but we can certainly figure it out. When I go from 3 to 6 to 12, I don't really even need to do any algebra. I can see that I'm actually doubling each time. So I'm multiplying by 2. My common ratio is 2. All right, and then the number of terms, all I've got to do is count how many I have. I've got 1, 2, 3, 4, 5, and 6. So n equals 6. Boy, this one should be pretty easy to do. All right, I'm going to go and just fill in this entire expression with the numbers. So I'm going to have 3 for my A1, and then open parentheses. I'm going to have the number 1 minus my ratio, which is 2, all over 1 minus my ratio, which is 2. Oh, I think I forgot something. I did forget something. I didn't leave any room for it. My exponent. Okay, so I need to have the n right up here. Okay, so now if you have a graphing calculator handy, you should get, if you type this all in, you're going to get 3 times 1 minus 2 to the power of 6 over 1 minus 2. You should get 189, or negative 189 over negative 1, which will equal 189. Not too bad. Okay, and what that represents is the total of all of these numbers. Of course, you could have typed them into the calculator. This formula really is helpful when you have a large series. Okay, now let's just walk through a couple problems finding the common ratio. And here's where I would actually, you may want to use some algebra to find out how you go from this number to this one. If you don't see it right off the bat, you could do it this way. I could say 1/3 times x, my mystery number, is going to equal 1/9. And then I could go ahead and solve for x. And how I would do that well, this is how I would do it anyway. I'd multiply both sides by 3. And those two would cancel each other out. So I'd have 1x equals 3 over 9, or x equals 1/3. And that would be my common ratio. Okay, I would say r equals 1/3. Okay, and hopefully in the next one it'll be just as easy. 6 times x equals 4. So what I would need to do is divide both sides by 6. And I'm kind of running out of room here. I'll just kind of stick it down there. 6 over 6 is going to cancel out. X equals 4 over 6, or 2/3. So 2/3 would be the common ratio for example number 2. There you have it.